What's up, people? I hope you're good. I've got this Proline laptop. Yeah, it came in with a faulty battery and I was supposed to program that battery. I managed to program the battery and to change the cells, unlock it and stuff. As you can see there, that's the battery, and the health is at 88% and the capacity is actually at 62%. But when I put it here, the battery is not working at all. Yet the laptop works with a charger. So I just made an observation, because when they actually brought it, they brought it as a laptop without the battery. Well, as a battery without the laptop. So when I gave them back the battery, they said it's not working. I asked them to bring the laptop, and here's what I'm seeing. So one side has to be positive and one side has to be negative of these two. So you've got your clock and data at the same time, battery present, but one side is positive and one side is negative. I don't know which of the two is. But when I'm doing this, when I'm probing this side, you can hear the buzz there. I've got a dead shot. You can see the reading on the multimeter there. 0000. 000. So this is a direct shot to ground. So even if I try to read it here by this inductor there, by the coil, you can see it's a 000. So there's something which is completely dead. Like, it doesn't have a low resistance or anything, it's dead. It's shorting everything to ground. So best is to take out the motherboard. I don't know what's at the back. We shall see when we get there. Okay. Just clear a bit of this to whatever's. Okay, cool. So I'm also sure. I think I've posted a video of something similar. It was an Asus laptop which also had a short on the battery connector. But for that one, you would get 19 volts straight coming to the battery terminals. This one has got a dead short. Okay, cool. Here's the motherboard. So let's check it out. I don't see anything which is really pointing me out to an obvious fault. This cap looks funny colored, but it's fine. It just has a funny color. So I would be forced to come and check around the battery connector and to see how the power actually flows from the main power row. I believe it's somewhere over here. Oh, where is it? Okay, coming from there. Coming from this side, you've got the current sense resistor over there. So I'll need to know from here how that current will flow to the battery connector. Yeah, it comes to this MOSFET. Yeah, it comes to this MOSFET over here. And then on the other side of this MOSFET, what do I have? I've got a dead short. Yeah. So on the other side, I've got 19 volts. Wait, this is weird. Okay. Okay, yeah, this is correct. So on the other side of this MOSFET over here. Okay, so the MOSFET I'm talking about, it's this one. So on the other side here, this is where our main power rail is. As you can hear, it's not buzzing or anything. And then on the other side, we've got a dead short. And this other side is the one that's connected to the coil over here. So definitely it's not a fault of this MOSFET, because on the other side it's not giving me a direct short in between. But now I need to figure out how does ground get to this. So let me check these caps over here. Yeah, they've got a dead short. These ones also. So the caps behind the battery connector have got a dead short. So do these, which makes everything weird. I don't understand. I don't understand at all. Because checking it from behind, right over here by the battery connector, right over here, you can clearly see here, this is the last pin and this is the other pin. You can clearly see that this and this is not the same. The cable runs and then it goes all the way wherever it's going, whereas this one, it's coming from a via which is underneath, yeah, which would be somewhere over here by this resistor. So that would make this side positive and that side negative. So now we need to figure out why we have got a short there. I don't know if we can try to kill the short. The reason why I'm saying I don't know is that it's a dead short, so it might just draw the current. I'm at 1.3 volts, so I'll feed the current. It's drawing 8 amps. Oh, okay, I've got a dead cap over here, somewhere over here. So let me just add some flux, and you guys can be able to see as it melts away or something like that. Okay, so there is the flux on a tweezer there, and I'll feed the current. So I don't know if you can see the smoke already. Yeah, it's melting like butter, and you can see the smoke. So our faulty component is somewhere over here. I believe it's actually this one. Okay, fire up the water station and we can remove it. Most technicians will tell you, like, if a cap fails and it's next to other caps in parallel, it's best to change them all. I believe that too. I wasn't gonna oppose. I believe that too. It makes sense to me, because when it failed, when it was failing, it was probably extending the load to the rest of the caps. I don't know if that makes sense or whatever, but it's just my theory. Anyways, let me grab a board which is similar to this one, where we can just have the same components. Okay, this is pretty much close to this. It is also a Proline, but not the same make. And I'll just grab from over there. Yeah, I'll just grab the cap from just behind the connector over there. Okay. So I'll first remove the one that I think it's faulty this side. I think it's the second one. Okay. Out. Let me check for the short again. Drop to ground, and we still have a short, so that's not the cap, or probably there's more than one dead cap, because that short was like zero resistance, nothing whatsoever. I'll check them out one by one. Short, yes, short is still there. Let's grab the other one. Okay. When I arrange them based on which one I took out first. Okay, cool. I'll check for the short. And the short is gone. Okay, cool. So now only one capacitor left and that short circuit is gone. So those caps, I put them right over here, right over there in this in these baskets, whatever they are called. I'm gonna check them one by one. This looks fine, no short, and this one no short also. So it was actually one dead cap, this one. But anyways, I'm just gonna replace all, I think four. All four, yeah, I can replace all four. I can replace all of them to make my life much more easy. So it's not wise to keep the heat for too long over here, because you can see there's plastic on the side. So possible I can just grab 3. I don't know if that will work. Oh no, it's not gonna work. It just started snapping off. It works if they are close to each other actually. So if they are really close to each other, you can grab them all. So 2. 3 and 4. Cool. So I actually dropped one cap. Oh no, there it is. So I can keep this one as well in case I lose another one, and I can just use it as a spare. Replace a replacement. Okay. Trying to put the I would say in such a way that it doesn't disturb me, and I have to lower the air. It was at maximum, the airflow. Okay, cool. So here's cap number 1, cap number 2. I wonder what happens if you create a website and you name it pedmosfets.com or .net. There's already paid caps, so you just say ped MOSFETs or whatever, ped resistors. Okay, cool. So it doesn't matter if these get to connect with each other or whatever, as long as it's on the same side, because they're in parallel. So I'm sure they are all intact. Yeah, they are not going anywhere. So let's check for our short one more time. And we do not have a short anymore. So I'll just put the motherboard over here by this fan, which I use for cooling motherboards. Louis Resman said you should not copy his design, the design of his rapid cooling whatever thingy. I'm sure he was joking though. I'm not saying. Yeah, he was probably joking. Anyways, yeah, I just use that. It's a desktop fan, so it's quite big, and then I'll just blow the air towards the motherboard. So yeah, that should be enough for me. Anyways, let me grab the laptop in the meantime, and yeah, we'll start from there. So yeah, I had actually plugged the battery, thinking that it was locked or something, or that it had come badly balanced. It was weird for me because I just did this battery a few days ago, and that's one thing that I'm noticing actually. I've had about 5 laptops now within a space of a week. Yeah, a week and some days. Whereby I program someone's battery and I give it to them. Then they start telling me the battery doesn't work. And when I ask them to bring the laptop along, I figure out that the laptop is actually faulty. The guy that brought me this Proline, he also brought me an Asus laptop. So that laptop, he was saying, both laptops, he said the batteries are not working. This one I figured out it's the laptop's fault, and then the other one, it's also a faulty laptop, because the other one, what it's doing is that it's it will switch on and then it will switch off, but if you plug a charger, the laptop works fine, and it will even tell you the battery has got 52%. So if you charge it, it will charge. It will actually increase the the battery percentage, because it was at 50% when I got it, and then it was now at 53, and I used it a bit. But then the thing is, the moment you take out a charger, it switches off. So it's something that I didn't understand at all. And it's a dual device. It's not only a laptop, it's also a tablet. So now the difference with that kind of a tablet is that it's not just a tablet. It's the tablet side is actually Android. Yeah, the moment you switch off the Windows side, the screen will turn black, and then it will switch on again as an Android tablet. So it's got two batteries which are separate. One is on the screen side and one is at the bottom, or the keyboard side, where the laptop side is. So I'm quite sure that's where the issue is with that laptop. Because if I decide to charge the battery, it will charge. But the moment I take out the charger, laptop will not stay on. So considering that it's an Asus, I would be convinced that there is a screw or a button or something that I'm supposed to press to enable the battery. It's a very common feature in Asus and Acer laptops, especially the ones with the internal batteries. So yeah, cool, that is in place. It's a weird design. It's very difficult to plug a keyboard on this motherboard. Oh, I didn't see at all that I was too zoomed on. Anyways, yeah, cool, I've zoomed it out. Okay, the rest I'll assemble later on. I don't know how it arranges. I'm just gonna need to put 2 screws on it so that the motherboard doesn't fall, and the battery as well. So I've got 1 screw on the screwdriver there. You can go there. I actually put the screws here when I was checking them out. Yeah, I can go here. Cool, motherboard is in place. Now I can place the battery as well. I wonder how this battery was. Oh no, yeah, it also it will automatically block the flow of current if it detects a shot. So that's why it didn't burn up or anything. So batteries are actually not just cells giving power. They've got a BMS within them, and that BMS is one that determines whether the laptop should be sending and receiving power or relax. So yeah, this one detected a shot and it cut the power. Okay, I don't see the laptop switching on. No idea why. Let me plug a charger first. Probably the battery needs to activate or something like that. Okay, I've plugged the charger and the battery is drawing 1.3 amps of current, so it is charging now. It was not charging at all, and when I press the power button, 1.6, 1.7, yeah, thereabout. And I'm just gonna expect the laptop to switch on about 3 times before it actually displays. So give it a moment. I don't know if you can see the green light in there, yeah, and then the orange light for charging. So it's about to display there. I've got a display, so I'll pull out the charger now, and boom, the laptop is fine. I can see I've actually pulled out the charger from over there, and it is still on without a problem. And I apologize for my light. I'm facing towards the sunrise, and yeah, there's too much light. Anyways, yeah, that's all there was to this. This laptop actually had a dead capacitor, and I didn't do a bad job at programming the battery. As you can see, the laptop is functioning 100% fine without a charger. So yeah, thanks for watching, guys. I hope you learned something, and yeah, I'll see you in another video. What I used actually was I'll probably need to make a recap. So what was happening is that the laptop came with a faulty battery. I changed the cells and I programmed the battery. Yeah, and everything was fine with the battery. I unlocked it and balanced the cells, everything. But when I put it here, it was not working. I gave it to the customer and they plugged it in, it was not working. So I asked them to bring the laptop and I discovered there's a short on the output of the battery. So that short was being caused by a dead capacitor there, which I managed to burn off using the short killer tool at 1.3, 1.4 volts. It was actually writing 1.3 when I did it. I don't know why it's at 1.4 now. Yeah, there you go. It keeps pumping up and down. Anyways, yeah, that's all there was, guys. And I've replaced the capacitors from this motherboard. It's quite similar to this, as you can see. Yep. And that's it. Thanks for watching, guys. I'll see you in another video. Cheers.